This is my very special girl, Lara. I'm so excited that Lara is helping us with this video because we are about to unlock the secrets of a geometrical universe. That's right, because today we're going to be working with special right triangles. Hey Lara, how about in this lesson, let's learn how to rationalize a denominator. Let's look at the 45, 45, 90 triangle. And you're going to see a special relationship. 45, 45, 90, very special triangle. The ratios of the sides are 1 to 1 to the square root of 2. Now this is a ratio. I could write it as a ratio, 1 to 1 to the square root of 2. And sometimes you'll see an x and an x and x times the square root of 2. But really this is a ratio of sides to the hypotenuse that we can solve any problem knowing this ratio. So the quick example that will illustrate this ratio is when you are given one of the legs of the triangle. Let's say one of the legs is 7. And we know that if one of the legs is 7, because it's a 1-to-1 ratio of the legs, the other leg is 7. I'll just say that's x equals 7. And we've identified the hypotenuse as the side that's across from the right angle. And we know, let's say that's y. Okay, y is the leg times the square root of 2. So that would just be 7 times the square root of 2. What if you were given the hypotenuse? Let's look. Here's my 45, 45, 90 triangle, and I'm going to call this 8. Okay, so the hypotenuse is 8, and I'm going to put x's on the sides. If I put an x and an x are equal, that means the legs are equal, and automatically we know that that's a 45, 45, 90 triangle. Now, if the leg times the square root of 2 is the hypotenuse, and you're given the hypotenuse, the leg is really the hypotenuse divided by the square root of 2. The leg times the square root of 2 is the hypotenuse divided by the square root of 2 is the leg. I have a mini lesson alert. This is a mini lesson that will help us simplify this expression. This was the answer that we got in example 2 of the last problem, 8 divided by the square root of 2. Now I'm not going to punch that in my calculator because I want my answer to be in simplified radical form. But there's a problem here because this is not simplified. If there is a radical expression in the denominator, we are going to need to rationalize the denominator. We need to rationalize the denominator. And that's a simple process that will help us simplify this expression, because when we rationalize the denominator, that means we're getting this irrational number out of the denominator, and we don't like to see radicals. If we're simplifying, we're not leaving radicals in the denominator. Oh no, we're not going to do that. We're going to do a very simple process of rationalizing the denominator, getting rid of that radical. Now I'm just going to multiply this by 1, which is something over something to get rid of that denominator. And I know from my radical experience that the square root of 2 times the square root of 2 is going to give me 2. So to get rid of this radical in the denominator, I'm going to multiply it by itself. And that would be the square root of 4, and then that would be 2. So the square root of 2 times the square root of 2 is 2. So I got that out of the denominator. But I don't want to mess up this expression by multiplying the denominator by the square root of 2. So I'm going to also multiply the numerator by the square root of 2. Very simple process to rationalize the denominator. Now, 8 times the square root of 2. 8 square root of 2. Done. Uh-oh. Can I reduce this 8 and this 2 because they are both outside of the radical whole numbers? I sure can, and all I'm going to do is come over here, 8 square root of 2. I'm going to cancel that 2, and that is a 4 square root of 2. That's the simplified radical form of the original problem. 8 over square root of 2 is 4 times the square root of 2. Now let's step it up a little and talk about 30, 60, 90, another very special right triangle. And this one also has a ratio of sides. So if we know we have a 30, 60, 90 triangle, we have a relationship between the lengths of all the sides. And that is up here. I'm just going to put it up here. 1 to square root of 3 to 2. Now, that's an interesting relationship, and I'm just going to write that down as 1 to square root of 3 to 2, and that's a ratio of the short leg to the long leg to the hypotenuse. I'm going to call that short, long, and hypotenuse. So, you know that the short leg is the shortest leg between the two legs, and the hypotenuse is the side that's across from the right angle. And so if I gave you any one of those sides, you could get the other two sides by using this ratio. Now, I'm going to give you the easy ones, and then it starts to get a little bit tricky, or if you love to rationalize a denominator, you're good to go. Now let's take a look at this quick, easy example. And I just put an example. I said, here I am. I've been given one side. In fact, I was given the short side, which is across from the smallest angle, the 30-degree angle, the short leg. And I know that the short leg has a relationship with the hypotenuse. In fact, the hypotenuse is double the length of the short leg. So I can go right on over here and get the hypotenuse pretty quickly, and that would be y equals 3 times 2, which is 6. Okay, so I'll just put that right over there, y equals 6. Now I've got to get the long leg. What's the relationship between the short leg and the long leg? It looks like the short leg times the square root of 3 will get us the long leg. So I'm going to come on over here and I'm going to write x equals 3 times the square root of 3. It's the short leg times the square root of 3 will give you the long leg. So I've got my y, my hypotenuse, always double the short leg, and the long leg is square root of 3 times the short leg. Here's a great problem, and I like to call it another one of the easier examples of 30, 60, 90 triangles, because in this situation, I'm given the length of one of these sides, but I'm going to be a little careful here. I'm going to say, where's the hypotenuse? I identify the hypotenuse. It's very important because we can see that the hypotenuse is not as you might think at first. Why? The hypotenuse is across from the right angle, and that is a 12. I'm going to put a little 60 here. That's a 30, 60, 90 triangle. The hypotenuse length is 12. So if we have a ratio and we know that the hypotenuse is double the size of the short leg. So I can go right on over here and get the short leg length is half the length of the hypotenuse. So I've got x equals 12 over 2, which is 6. That was easy. X equals 6. Now, to go from the hypotenuse to the long leg, that's going to be pretty tricky. I invite you to do that in higher levels math. But right now, let's just keep it simple. And let's say the short leg times something will give us the long leg. Well, I know what that something is. The short leg, or the long leg, is the short leg times, what's that fancy radical on a special right 30, 60, 90 triangle? Square root of 3. I like to call this the uh-oh example. And this is the uh-oh because when you're given the long leg, you have to work with the radical a little bit, and you have to do something that's not too bad. Rationalize the denominator. Why? So let's look at this. The hypotenuse is across from the right angle. So the hypotenuse is y, and the short leg is x. Well, we know there's a very nice whole number relationship between the hypotenuse and the short leg. It's a 1 to 2. So we know that the short leg is half the hypotenuse and the hypotenuse is double, but we don't have either of those. So we can't do that quick, easy whole number trick right off the start. We're given the long leg. And the best way to get any of these is to go through the short leg first. So we're going to get the short leg first. So I'm going to get the short leg. Well, if the short leg times the square root of 3 is the long leg, then the long leg divided by the square root of 3 will give us the short leg. Here's the uh-oh. We have a square root of 3 in the denominator. Well, it's not really that much of an uh-oh, because to get rid of that, we're going to rationalize the denominator. Here we go. Square root of 3 times the square root of 3, and that gives us 5 square root of 3 over 3. Can I reduce that? Really? No, I'm not going to rewrite that. I've already reduced 5 and 3. I mean, that's pretty much reduced. So that's my x. Well, that's the short leg. Once I've got the short leg, oh boy, I can get that hypotenuse. All I have to do is multiply the short leg times 2 to get the hypotenuse. So here we go. Y equals 5 square root of 3 over 3 times 2. Now this is really just manipulating numbers, or learning the mechanics of multiplying numerators and denominators when there's radicals involved. 5 square root of 3 times 2, you can multiply those two whole numbers. That's going to give us 10 square root of 3, and that's over 3. Well, I can't reduce the 10 over 3. 3 doesn't go into 10 evenly, so I'm just going to leave it like that, and that's a perfectly acceptable answer. Here's your you try. Pause, write them down, try them on your own, And then in the next section, let's watch the quick solve, and I'll solve all of these problems. But you don't want to just watch me solve them without trying them first, because that will eliminate great practice. So see if you can do them on your own first. Thank you for helping, Lara, and thank you for watching.